Number one, wow, this is cattywampus. There we go. All right, number one, definition of displacement. Displacement is the straight line length between 2 points. Okay, so straight line length between 2 points. Keep in mind that this is not the same as distance. Distance is how far you go. Displacement is not how far you go. Displacement is how far it is between two spots. So, for example, if this is like the classroom, okay, so here's the room, and here's some desks. If I go from A to B, this would be my distance, but this would be my displacement. The biggest thing, well, I'll get to it in a second, never mind. All right, an equation. Not so much an equation, but how do you find it? The way you find displacement, so displacement is either d or delta x, depending on if you had honors or physics 1. So d or delta x, you do it by taking your final position minus your initial position. So basically you take your final spot, final position, minus your initial position. So you just take where you ended up minus where you started. You have to be careful about directions. If you're talking about like two-dimensional stuff, usually we'll deal with one-dimensional stuff. But you do have to be careful about directions a little bit. But I do want to make sure that you see how would you go about finding it. You take where you ended minus where you started. So what are some things to keep in mind? So the first thing to keep in mind is that displacement does not always equal distance. It can, if you go in a straight line. But if you don't go in a straight line, they're not the same. You should also keep in mind that you do not need to travel your displacement. Okay? Here's what I mean by that. I don't have to actually walk that route for it to be my displacement. Okay? I just have to I just have to measure it. So if I go from here over like to the shower, okay, and I walk, 1, 2, 3, this is how I get here, I'm walking, I end up back here. This would be my distance, right? My displacement would be from up there to here. I don't actually have to, walk that distance. I don't have to actually walk the whole way. I'm not going to step over your stuff. I don't actually have to walk the whole way to here for it to count as a displacement. I just have to measure it. So don't assume you have to go the displacement for it to be a displacement. Displacement is just a measure from A to B. The reason why we do it is because it gives us direction, right? If I told you, if I'm standing here, okay, and you all closed your eyes, and I said, okay, I took 15 steps, where am I? You would have no clue where I was. None. I took 15 steps. I could have gone through the window for all you know. Maybe I put headphones on. How do you know? You don't know where I ended up. But if I said I went 15 steps southwest of my position, assuming you know cardinal directions, you could figure out where I was. Okay? Assuming you know where north is. Okay? You can figure out where I was. So that's why displacement matters. Distance has no direction, displacement does. And that's my... Oh, I like I've been recording while I've been standing in the back of the classroom. Good job. But that'll show up real well on the sound.
So the next thing you need to keep in mind is that displacement has direction. And lastly, displacement is 0 if you end where you started. Okay? So then I get to my qualitative example. Okay, so I need an example to explain things. Okay, I'm going to explain track because there's an Olympics going on. So in track, the athletes travel the same distance. Not the same displacement. Okay? If you've watched them do a race, and oh my gosh, I'm about to draw things. I apologize in advance. Here's my track. Oh yeah, it totally looks like this. And it has the different lanes. The reason it has different lanes is because you need different places for people to run. But if you notice when they do a race, they don't all start in the same spot. At least, you know, for races where they have to go any significant different distance, like the 400 or 300, or there's not a 300, 400, 200, something like that, right? So this person will start here, this person will start here, this person will start here, something like that, and then they travel all the way around. And then they end at the same place. So while they all travel 400 meters, that's their distance, not their displacement. The displacements are different. This person has a smaller displacement because it's where they ended minus where they started. This person's is a little further. This person's is a little further. It also will have different directions, so don't assume that they're going to be the same. Okay? Sebastian, can you take your headphones out for me? Thank you. Yep.
I don't see how the track runners run the same distance.
Huh? How do they run the same distance?
Yeah.
So because the person on the outside has a larger circumference, if they started at the same place, their circumference circle that they ran would be larger. So what they do is they start further up on the circle than the other person does.
Okay.
Yep. That's why they do it that way. Yep. All right. That's also why, like, on some of the races, they do, like, a staggered start for part of it, and then they all, like, get in the same lane and knock each over and that kind of stuff. All right. And lastly, a quantitative example. So I'll say something like, let's not use a different color. So driving from mile marker 73 to 100 and let's make a happy number, 113 is a displacement of 40 miles. Right? I took where I ended minus where I started, and that's my displacement. I'm assuming I'm going in the same direction. Obviously, if I'm going in different directions, that gets more complicated, and so on and so forth. So this is how I want you guys to do the notes. You're going to do the same thing for either velocity or acceleration, whichever one I assign you. You're going to give me a definition of it. You're going to give me an equation to use. You're going to tell me some important things to keep in mind. These are things that help you understand velocity or acceleration better, or things that are confusing about them, right? For example, a good thing to talk about with acceleration is what's up with a negative acceleration, because it doesn't mean slowing down always, okay? Another good thing would talk about, like, what's a negative velocity mean? Okay, those are some examples. What are some weird circumstances of these things? That kind of stuff. When you're talking about acceleration, how can you accelerate? There's two different ways to accelerate, not just one. And I'm not talking about speeding up and slowing down. That's one way. Speeding up and slowing down are the same thing. There's just opposite directions. Okay? Then you're going to give me qualitative examples. So one example that describes it, and then a quantitative example, one mathy thing that describes it. Okay? That can even be like a super easy problem if you want to make it up. Okay. So you're going to do that for your section, whichever you have, either velocity or acceleration. And you'll notice I have the page numbers listed there. So velocity starts on page 41 and goes through 43. Acceleration starts on page 43, and there's some stuff on there for it. I do have, if you need to take, I've been having issues with the online book. And so if you don't finish it in class, which I'm almost certain we will here, but if for some reason we don't, if we don't get it done in class, if you need to take it home and your computer's not working, I do have a couple of hard copies. They're shrunk down, so they're kind of hard to read, which one, having to use your own book or looking it up online. Either one of those is fine. So I want you to go ahead and get started. I will come around and tell you which one to do, either velocity or acceleration. Actually, let's make it easy. If you're sitting in the right seat at your table, okay, unless you're at a table by yourself. If you're at a table at yourself, ignore this. Let's stop recording it while we're not talking about anything useful.